Dear students, today we will solve the question number 9 from chapter number 4. This is physics class 9. The numerical states that one girl of 30 kg mass sits 1.6 meter from the axis of a seesaw. Another girl of 40 kg mass wants to sit on the other side so that the seesaw may remain in equilibrium. How far away from the axis the other girl may sit? Dear students, here is a diagram. Let be this be a girl of 30 kg mass, and she is sitting at a distance of 1.6 meter from the seesaw's axis. And another girl, she has a mass of 40 kg. Now we are asked that where should she sit that the both are in balanced or in equilibrium. Let's write the data. Mass of the first girl, let m1, this is equal to 30 kg, and the force exerted by this girl, let it is F1, and force will be equal to the weight of the girl, and weight is calculated by multiplying mass, which is m1, with the gravitational acceleration on the earth. Its value is 10. So mass is 30 and the value of g is 10. So the force which she will exert on the seesaw will be 300 Newton. And its distance from the axis of rotation or the axis of seesaw, this is 1.6 meter. I write it as L1. Moment arm, this is 1.6 meter. Similarly, mass of the second girl, which is represented by M2, this is 40 kg, and the force exerted by the second girl on the seesaw will be F2, and it will be equal to weight of the girl, represented by W2, and weight is calculated by multiplying the mass, which is M2, with the gravitational acceleration G. M2 is 40 and the value of G is 10. So multiplying 40 with 10, we will get 400, and since this is a force, its units will be Newton. And its distance from the axis of rotation, that is L2, we have to calculate. We put the question mark here. According to the principle of moments, clockwise torque is equal to the anti-clockwise torque. The 30 kg mass girl will produce a clockwise torque, and the 40 kg mass girl will produce an anti-clockwise torque. So I write here that A for anti, C for clock, and W for wise, and T for torque. Anti-clockwise torque is equal to clockwise torque, C W T. This is called the principle of moments. According to this principle of moments, the F1 multiplied by L1 will be equal to F2 multiplied by L2. Now we put the value in this equation. I write here F2 is 400 Newton. I write here 400 and multiply by L2. We have to calculate L2. I write it as it is equal to F1 is the weight of the first girl, which was 300 Newton, and L1 is the moment arm of the first girl, which is 1.6 meter. So to calculate L2, we will divide 400 on the other side, 300 multiply by 1.6 and divide by 400. Cancelling 400 on both sides, sorry, two zeros on both sides, and 4 ones are 4 and 4 fours are 16 and 4 threes are 12. So the L2 distance is 1.2 meter. It means that the 40 kg weight girl uh, should sit at a distance of 1.2 meter from the pivot, and here it was 1.6 meter from the pivot. So it means that the smaller math student should sit closer to the pivot point, and the larger math student or girl should sit away from the pivot point. Once again, I repeat this question: how to solve this? We are given the masses of the two girls. The mass of the first girl is 30 kg, and its weight will be equal to m1g. Multiplying 30 with 10, it will be 300 Newton, and its distance from the seesaw, it is 1.6 meter. Similarly, mass of the second girl, it is 40 kg, and the force it will exert downward will be equal to her weight, and it can be calculated by m2g, and it is 400 Newton. And its distance from the axis of the seesaw L2 we have to calculate. Since both the girls will produce torque, one will be the clockwise torque and the other will be the anti-clockwise torque. The 30 kg mass girl will produce clockwise torque and the 40 kg mass girl will produce anti-clockwise torque. So according to the principle of moments, clockwise torque is equal to anti-clockwise torque. So F1 L1, here it will be L1. F1 L1 will be equal to F2 L2. So putting the values and simplifying, we get that the L2, that is the distance of the second girl from the seesaw axis, is 1.2 meters. Thank you very much for watching this video. See you next time.